Application. Okay, here, check this out. We got airplane problem. An airplane leaves the airport at 5 p.m. and it heads due west at 300 miles per hour. At 7 p.m., the airplane changes course to south 35 degrees west due to bad weather at the intended destination. Draw a diagram labeling any angles and distances provided. So if I didn't know what was going on right here, I would just start with a dot, okay? Here's a dot. This is going to be my airport. And then the first thing that happens is that the plane flies due west, starting at 5 p.m. And then something happens at 7 p.m. Okay, and what are we doing? Like, how are we traveling? We are traveling at 300 miles per hour this way, okay? And then what happens after that? We change our course. And here's our course change. I've got another bearing right here. In fact, I'm going to go ahead and circle all my numbers because all my numbers are pretty dang important whenever we have word problems to work through. So then, okay, so how do I do that? How do I do the bearing? It says south first, so I'm going to point an arrow down south. And I'm going to do this little compass thing on the side to remind myself that that's north. And then this would be south, and this would be east, and this would be west. So if we're going down south, pretend you're facing south. Which direction would you be turning if you're facing south? Would you turn to the right, or would you turn to the left if you're going 35 degrees west? You would go to the right, okay? So then I would go this way. So I'm going to draw my line like this, and I'm going to draw a new dot. And this is also going to be 300 miles per hour this way. Okay, so that's what I have so far. Now the directions say draw a diagram, label any angles and distances that are provided. And then let's go ahead and label this angle right here. This angle was 35, right? 35 right here. Okay, 35 degrees.
But how do you know
okay.
that it goes another hour?
How do I know it goes another hour? I don't. I just know that we're going 35 miles per hour. This is not a distance. This is a speed. So same with this is a speed. Okay, but do we know anything else? Is there like a hidden number that I could throw up here? 600 miles.
Good job, Christina.
Now, how the heck did we get that? See, if we start at 5 and we change course at 7, how many hours did we go 300 miles per hour? We went 300 miles per hour for 2 hours, which means we traveled a total of 600 miles. That's all I got. That's it. That's it, people. Okay, let's go to the next one. Find the distance the airplane is from the airport at 10 p.m. So if I go back to my graph, I am looking for this. I'm looking for that distance. What is this distance? That's what I'm trying to find. So how can I find that distance? Hoi. Well, I know a distance formula, but a distance formula requires a right triangle because a distance formula comes from the Pythagorean theorem. Okay, do we have a right triangle anywhere? Yes, we have one right here. But does that give me the length of the whole side? No. Rats. Okay, so that right triangle is not going to help me out. And this right here, this triangle, I don't know if this is a right triangle. Maybe I can fudge this a little bit and make this into a right angle right here, but that's not accurate. So that's not a right triangle either. Hoi. So here, I want you guys to think really quick to back in the day in algebra, you guys had to find the distance between 2 points. So you're looking for this. What would you do? You would draw a right triangle like so. And then you do Pythagorean theorem, and then you would be able to find the distance of this slanted line. And that would work for any 2 points. I could put a point here and a point here, and I'm like, okay, guys, what is the distance between those two? And then shebang gadang. All right, we got another triangle like that. So as long as we get a right triangle somehow with 2 points, which we can do with any 2 points, we can find the distance between 2 points. Now, we got 2 points right here. We have a point right here, and we have a point right here. So, is there another right triangle that we can draw?
Yeah, a big one.
Yeah, we can draw a big one. Okay, so I'm going to extend this line here, and I'm going to go down like this, and boom, we got our right triangle. Look at this food, guys. We have a right triangle. Look at that. All right. Okay. Now, what are we missing in this right triangle? We're missing a couple of things. We need, we got this distance. We need to know this distance. That way we know the length of the whole thing. And we need to know this distance right here. So if I could find those distances, then I would be able to use the Pythagorean theorem to find that distance. Oh, man, we got a lot of work to do ahead of us. Okay. Now, did this give us any other extra information that we can use on our graph?
Yes.
Oh, snap. 10 p.m.? Oh, there it is. Okay, so 10 p.m. So now we know this is 10 p.m. down here. So what is the distance of this guy? 900. Okay, I'm going to put 900 over here. I'm kind of running out of space over there. Okay, so that hypotenuse is 900. And boom, we have our smaller triangle that's going to help us find the distance of this line and this line. Ooh, so we got our smaller triangle. Let's draw him right here. Okay, I'm going to label some sides here. I'm going to call this side X. I'm going to call this side Y. Any labels you guys want, I'm going to put those right there. And if I find those two, then I can use the Pythagorean theorem. Okay. Is there anything else I know about this triangle? Because right now, all I know is that this is 900 right here. But I don't know. Well, I don't have anything else on my picture that's going to help me actually find those other ones.
55 degrees.
Oh, 55 degrees. What the heck? Where did that come from? You see this angle right here? Here, I'm going to draw on it. This angle right here is a right angle. You guys see that right there? That's a right angle. And we know that this part is 35. So what would this have to be to make it a total of 90 degrees? 55. So essentially what we're doing is we're taking 90 degrees and we're subtracting 35 degrees to get 55 degrees. And so we know that this angle right here is 55 degrees. Now, because we have an angle on one side, we can find any other side of our triangle simply using, what's it called? Trigonometry. Oh yeah, that's right. It's trigonometry time, people. All right, so what trig function do you guys want to use if you got this one, and this one? That one would be cosine. See, we got cosine, and then we would plug in 55 degrees, and then we would write the adjacent side, which is x, divide that by the hypotenuse, which is 900, and then we got to get the x alone. So how do we get the x alone? Looks like a 900 is dividing the x. What is the opposite of dividing?
Multiply.
So we're going to multiply. Peace out, 900 right there. 900 is now on the other side. In order to find x, we have to multiply 900 times cosine of 55 degrees. And you guys are doing that right now to tell me the answer. There you have it, 516. Did you guys all get that? If you didn't get that, you might not be in degrees. Make sure your calculator is in degrees. And notice that nothing in our problem says where to round. If it doesn't tell us where to round, then we always round to the third decimal place. All right, the next one we're looking at, we got 955 degrees and y. That would be the sine function. So I'm going to go sine of 55 degrees. That would be opposite over hypotenuse. And so we get y divided by 900. Then we have to multiply by 900 to both sides because that is the opposite of division. And now I get y is approximately equal to, and what do you guys get when you guys do that? It's 737.237. Now x and y. Now this is not my answer. Did I answer my question? It says find the distance the airplane is from the airport. Nope. I gotta find the distance right here. So we gotta use these two numbers to do our Pythagorean theorem. Oh snap! This never ends. Let the pain stop. No, it's not painful. This is exhilarating. Okay. Yes, it is. It's exhilarating. I am exhilarated. Okay. So we got this side right here, which is our y. So that's going to be 737.237. And we're going to square that foo. And we're going to add to that. Ooh, what would that be? 516.219 plus 600. Don't forget to add that. What do we get? We get 1,116.219. Are we good? Is that right? Yes? We got to square this dude, and this equals c squared. Can you guys please tell me what c squared is approximately equal to? You have to square those and add them together. So if you're using the rounded answers, which is what I'm doing, I'm using the rounded ones right here and here. You get this for your c squared, and then we have to square root that foo. Now if you use the more exact answers, meaning like you kept the 900 times cosine of 55 and the 900 times sine of 55 and squared those, your answer will be close to mine. It won't be exactly, but it'll be close. All right, what is the square root of that? What do you get?
1,000.
There you have it. Now that's in miles.
Yeah.
Boom. That was gnarly. So I dropped down the picture from earlier to answer this question. Now I think this is a bad question. It says find the bearing of the airplane at 10 p.m. It should say in relationship to the airport or in related to the airport. So we're going from the airport. What is the bearing from the airport? So that's really taking. We're gonna go south because this bearing looks like it's closest to south, and we gotta find this angle. So that's what we would do. And if I'm going this direction, that means that's west. So I got my answer is gonna be south west. Okay, we're going south, but so many degrees west. So we gotta find those degrees, and in order to do that, we're gonna have to bust out those inverse trig functions, because in order to find this angle right here, we need to know what this angle is. We could find this angle if we have two sides, and we do have two sides. We actually have all the sides. So I'm going to use the rounded numbers. You don't have to use the rounded numbers. You can use the more specific numbers, but I'm going to use the rounded numbers. I'm going to use arctangent, since I'm going to use this side right here, that's the opposite, and the adjacent. Could you use any inverse trig function? Like, could you use arcsine? Yes, you would do opposite over hypotenuse. Or you could do arccosine, and that would be adjacent over hypotenuse. But I don't like using multiple rounded answers. Like, this answer right here we got because we used a rounded answer here at the top and a rounded answer here on the left. And then, so this is almost like a doubly rounded answer. That's not academic the way I said that, but I think that makes sense. So I'm going to use tangent for this one and this one. So let's just set it up. Let's go. Tangent of theta, which is what I'm looking for, is going to be, and what are my two sides there? Okay, so I got this side right here, which is my y, the opposite, divided by the adjacent. Now, if I was looking for theta, now I normally wouldn't set it up like this. I would go straight to arctangent, but I'm doing this for you guys.
Yeah, that's what I do.
If I want to get rid of theta, if I want to get rid of tangent so I can get to theta, what would I have to do to this side to get rid of tangent? Arctangent. Now, I'm writing arctangent, but you can also write it as tangent to the -1. That's the same. Okay, this is the same as that guy. So now I have, these cancel each other out. I'm left with theta right here, but then I have to do this to the other side. Arctangent of this side. So you got to throw that into your calculator. What do we get? So we get 33.444 degrees. Now, what did we find? Did we find that degrees that goes in here? No. We found this one right here. We found this, the measure of this angle. So how are we going to find the measure of that angle? Yeah, this is 90 degrees right here. So we're going to go 90 degrees minus 33.444 degrees. We got 56.556, and that's what we put in right here.
So, what was the 33? Is that the one that...
So you
The
divide
33 is this angle right here,
Okay, got it.
but we needed this angle right here. So facing south, we turn 56.556 degrees towards the west. That is our new bearing.